Okay, so today we're doing piecewise and step functions. We're going to learn about it. Piecewise. Well, you hear the word piece in there, right?
Yes.
It's going to be in pieces. Okay? Step functions look like, guess what? Steps. They look like steps. Okay? Step functions you're going to be introduced to, not going to use very much, but we'll talk about them and where they're used, but it's not something you deal with a lot. Okay? Did that jump 2 or 1? Okay. Now, this is a piecewise function. It's called a piecewise function because it has what? Pieces. Do you see it?
Yes.
There's 3 pieces. Over here, there are 3 domains. This is not the function. If my number falls between -10 and -2, I use the top function. Get it? If it falls between -2 and 2, I use what? The middle function. If it falls between 2 and 10, I use the what? The bottom. Anything smaller than -10 or bigger than 10, does it exist in this equation's world? No. So if I were to ask you, this has nothing to do with graphing, so you do not have to write it down. If I were to ask you, what is f of 3? Which one of those does 3 fall into?
The bottom one.
The bottom one. Because 3 is between 2 and 10, correct? So then I would plug in 3, and 3 plus 1 is what? 4. So what about f of 2?
The bottom one.
Mm-mm.
Or no, the middle one.
The middle one. Why is it the middle one and not the bottom?
Greater than
Equal to.
greater than equal to -2, greater or less than equal to 2.
Right. So the middle one, 2 isn't included, and the bottom one, 2 is not included, is it? So I'd plug in my 2. 2 squared is 4, minus 1 is 3. Do you see how that works? What? You need to give me a question. What don't you understand about that? So I can answer it. I seriously want to answer. You said you don't understand, so what don't you understand?
What am I doing with those?
We have, okay. I want to know what is f of 3? Does 3 fit into this group, or this group?
But how is
Does 3 fit into the first domain, second domain, or the third domain?
it's between 2 and 10?
It's between 2 and 10. 3 falls between 2 and 10, correct?
Yes.
So I plug 3 into what equation? That equation. So 3 plus 1 is 4. Okay, now I want 2. Where does 2 fall into? The first equation, second equation, or third equation?
Second one.
The second one. So I plug in 2. 2 squared is 4, minus 1 is 3. I'm evaluating a piecewise function. That's what I'm doing.
So that's all we do?
Well, no, that's all I was doing right there. That's not what this says. This says do what? Graph it. Okay, I was showing you how they worked. So when I graphed this thing, when I first learned out, I was like, I have to graph all those at one time, and that's what your brain's doing right now. That is not what we're going to do. We are going to do one piece at one time. Got it? So, equation 1. So, E1. Where does it start? What's its first number for equation 1? What's the first number?
4 and 4.
No. What's the first number? -10. Yes, that's the first x.
Yeah.
Okay, so I'm going to plug in -10. So 4 minus 10, or 4 times -10 plus 11. What do I get?
-33. Or
No.
-29.
-29. Okay, so that point would be -10, -29. Yes? I plugged in an x, got out a y. All I'm doing. What's its last point in that domain? It's the last point in that domain. -2. So guess what I'm going to plug in? -2. So 4 times -2 plus 11. So I get -8 plus 11 is 3. So that point is -2 what? 3.
Wait, oh wait.
Okay? So all I did. I know the start and the stop. What shape is this? Isn't this linear? So it's going to be a straight line joining those 2 points, correct? Now, negative 29 is nowhere on this graph, is it? No. But I'm just if we had it on our graph, we would. Okay, so now what we're going to do is negative 2, 3. Is that an open or closed circle at negative 2? Look up here at your domain.
Closed. No, it's open.
It's open. Why?
Because it's parentheses.
Right here, why is it open?
Oh,
There's no
Yeah.
line.
Because it's not equal to, correct? So at negative 2, 3, I'm going to make an open circle. So at negative 2, 3, hopefully you're doing this on your graph paper. Negative 2, 3. I can't really make an open circle, so I guess I'm going to do that. Open circle. Yes? Now, I cannot do negative 10, negative 29 on this graph, can I? But since this is linear, can I just count my slope over here to the left? Yes. What is my slope of 4x plus 11? What's the slope? This equation, what's the slope? 4. Okay, correct? So if I go down 4 from that, 1, 2, 3, 4, that means I have to go left 1, correct? So that would be, I got to change my marker. And then I got to change my color. So it would be 1, 2, 3, 4. So that would be at negative 3, negative 1. Yes? And then could I do it again? 1, 2, 3, 4, 1. And 1, 2, 3, 4.
Wait, why? Wait,
3,
why
4.
are these closed?
Because they're not an endpoint. These new dots aren't the endpoints, are they? They're in between. The end is the only thing not included. Everything else is included in there, isn't it?
So you're going down 10?
No. What is the slope?
down 4 over 1.
I'm going down 4, left 1, because if I go down 4, that's negative, left 1's negative, and a negative and a negative makes a,
Yeah.
because it's y equals mx plus b. You guys can't forget yesterday for the sake of today. When you see 4x plus 11, should you know that's y equals mx plus b?
Yes.
Yes. Okay, the slope is 4. So I go down 4 over 1. Now, can I connect those dots?
Yes.
Yep. So I connect them over here. And I have to stop, well, at 10. There would be a closed circle at 10, yes? At negative 10? Well, not at negative 10. I'm sorry. This would keep going and going and going and going and going. Clear to get to negative 10. Yes?
Negative 29.
Yeah, negative 10, negative 29. I'm taking x. X, negative 10, I'd have to go down to 29, but I don't have it on my paper. Don't write it on your paper unless you want to go by a different scale. Got it? Now, did I get the first piece done? Is that from negative 10 to negative 2 done? Yes? So now I'm going to do from what to what? Negative 2 to what? 2. So, equation 2, I got to pick a different color. How about red? So, equation 2. So, what are my endpoints for that? Negative 2 and 2. So, I'm going to plug them in. Everyone follow? So, negative 2 squared minus 1. Well, what's negative 2 squared? 4 minus 1 is 3. So, that point is negative 2 what? 3. So, then I'm going to plug in the other endpoint, which is what? 2. So, we have 2 squared minus 1, which is 3. So, that point is 2, 3. Now, this is x squared, which is quadratic, which the shape is a what?
Probably
A parabola.
problem.
So does that make sense that it's negative 2, 3, and 2, 3? Yes?
Yes.
So it's going to dip down, correct? So I'm going to put a point at negative 2, 3. Now I can make this one fill it in, but it's not filled in for the first one. It's filled in for the what? Second one. See how it's red? See it?
Have like a new graph for mine?
Nope, but it needs to all be on one because it's all in a group. And then the next one is 2, 3. So there. But what do we know this graph does? Makes a parabola, doesn't it? So we need to find the vertex. And remember, the vertex is right in between 2 points, right? So what's the number exactly between -2 and 2? 0. So maybe I should plug in what? 0? So 0 squared minus 1 is what?
-1.
So it's 0, -1. That is going to be, that's a 1, not a 3. That's going to be my vertex. So 0, -1. Now can I draw my nice part of my parabola? I connect here. And do what? I'm getting better with that pen.
I have a question.
See that? Yes.
So for like on the 2, 3, it was like open, like the top one was
Mhm.
open, but now it's closed, right?
Well, it's closed because of the second equation, not because
No,
of the
it
first. This one was open. Right here was open because of the first equation was open, but I've closed it on the second equation. They happen to overlap. Sometimes they don't. Okay?
So if they overlap,
It closed in the circle.
okay.
Okay? But sometimes, like, Carly, one may end here, and this one may have started here, down here. So it just depends. Okay? So we're done with that one, right? We did -2 to 2. Connor. Now where do we need to go?
To the third.
To the third equation. Okay, so equation 3. What's the first number we're going to put in?
2.
2. Why 2?
Because that's the first thing.
Because that's the left endpoint, correct? So 3 plus 1 is,
3.
or 2 plus 1 is 3. You knew what I was saying, right? So 2, 3. And what's the next one I'm going to put in?
10.
10. So 10 plus 1 is
9.
11.
11.
So I have 10, 11. Now, what shape is x plus 1? What kind of an equation is that?
Linear.
Linear. Okay? So it is linear. Now, this doesn't exist right here.
How'd you get 10?
Like,
Doesn't?
past those points doesn't exist.
Okay.
Because our domain doesn't exist. See how I stopped and didn't keep going? What?
I don't know, I just messed up. I did 10 plus 1 equals 11, and I got 11, 3, but I don't know how I did that, so.
No, you put the two y's together instead of your x, y, x, y. Okay, so this is linear. Why should I know x plus 1 is linear? Why should I know that? What's the exponent on that x?
0.
1.
1 right there.
What's the variable, I guess? That should be 1, right? So it's linear. So I'm going to go put a closed or open at 2, 3.
Open.
Open, but it's technically already closed, yes?
Yeah.
So these two happen to meet. So I'm going to start there. And then I'm going to have one at 10, 11. So 10, 11 actually is on my graph, isn't it? Okay. Now, I'm going to have a hard time drawing a straight line, so could I count my slope here? What's my slope?
1.
1. So up 1 over 1, right?
How
And
many
there it is.
graphs will we be making?
I don't know. Oh, today?
Yeah.
I think I have 3. So these happen to overlap, but sometimes, like I said, you'll have the parabola down here, so you will have some open and closed circles, okay? The other thing is Angela extended, I'm going to just use the example. Sorry, Angela. She extended this, but can I extend this? Because my domain on that one only goes from what? -2 to 2. And all that dotted is past -2 and 2, isn't it? Now, you will have teachers, I think my teacher the first time, she's like, oh, just draw the whole thing and erase. Okay, yeah, that's all great and wonderful, but I press like I need to go through 6 pieces of paper. Anybody else in here? Like, I feel like I got a lead hand. And it's hard to erase sometimes, right? So if I do my endpoints, was it easier just to connect those and stop? Yes. Okay, so let's do another one. because he just takes practice. So I have how many equations again?
Those change?
What?
Oh, what the heck?
What, Jane? It's another example.
I thought they all like stayed the same and you're
No.
putting numbers into it.
No. Because I got different equations, don't I? Do I have endless amount of equations I could throw out there? Yep. Okay. If you graph housing markets, it does this because does housing costs stay the same? Is it always the same?
No.
No. Sometimes it raises really quick. Sometimes it drops and then comes back up, right? And then it can go slower again. That could be one. Okay, so I have 3 equations again here, yes. Where is my furthest left I'm going to use?
-6.
What's my biggest number I'm going to use?
-2.
No, in the whole thing.
Positive 10.
Positive 10. So I'm going to go -6 to positive 10, right? The first equation, is it linear, quadratic, absolute value, square root? What is it?
It's y equals mx plus b.
It's y equals mx plus b, so it's linear, yes?
Yes.
So what am I going to do first? You guys remember?
Put the thing in the thing and add it together.
Put 6 for 2.
Okay, -6.
6 in for x.
So 2 times -6 plus 5. So -12 plus 5 is
8,
7.
7.
And so that point is -6, comma 7. Where did those two numbers come from?
2.
Our thingy above.
Okay, -6 came from our domain, which is x, yes. And 7 came from after we put in a domain, we get out a range or a y. So I'm going to put a point, open or closed, at -6, 7.
Close.
Closed. Why closed, Angela?
Because underneath of your less than sign, it has to equal with it.
Right, it's less than equal to. So I have a point, yes?
Yes.
Okay, so now I go to negative what? 2? So 2 times -2, what?
Is it -7? Could it be -12 plus 5 is -7?
Oh, it would be -7. Thank you very much. Okay. I was like, it's going to go off the paper. Nope, not if I would have done it right, huh? Okay, -4 plus 5 is 1. Is that what you guys get? Yes, no?
Because I'm getting.
Okay.
It's slow writing with my left hand. I'm getting it.
Wait, what is that?
Hold on. For that, you put -6, -7, but you put it on 6, 6 on the graph.
No, I didn't. It's below. It's on -6, and then it's below. Like, it's 7 is right there, because
What?
-1 is there. On mine, this is -1, -2, -3, -4. See my lines?
Oh.
Oh, the middle ones.
Like,
Yeah.
-1 has numbers on it, so you can't see it. Okay.
Is it gonna be -1?
No, because it'd be -4 plus 5.
Yeah, okay.
Okay, so -2, 1. I'm just plugging in numbers, getting out x's and y's, correct?
Why is there an I there?
A what?
So it's a 1.
It's a 1.
Oh, there's a dot.
I was pointing towards the 7. Okay, so -2, 1. Okay, what kind of an equation was this?
Linear.
Linear, so what do I do with them?
Connect them.
Oh, wait, was this? Oh, these were supposed to both be closed, correct?
Yes.
Okay, so do the next one on your own. Might need to pick another point on number 2 like we did before to give you a better idea because it's a parabola, right? It's not a straight shot. You're going to have a curve in there somewhere, correct? How do I know number 2 is a parabola? Because it's x squared. So I'm going to give myself another point to give a reference where I can curve a little bit.
Again,
So I just plug in any number.
You plug the 2 endpoints and then something
When I
in
take it
between the two.
times- When I take it times the actual 2 first and then square that whole thing together.
I forgot to multiply by 2.
that's why I
You would square it. You would square it and then.
Multiply by 2.
Mhm.
Okay.
You plug it in the endpoints and then another point. That's all you're doing. Just what we've done on the last 6 equations.
Okay, so I have a question. So how do you know like what to plug in and I don't know.
The endpoints right here. That's what I'm plugging in.
But how do you get 2 on the other one and I have 3 on
Wait,
this?
so what you
That's
have
why I have
is
negative 2.
Yeah, what I had was wrong.
2 is
Yeah, because I forgot to multiply by 2.
7, 4 times 2 is 8, and 7 is 1. So it's,
Messed up all over.
so it's 2.
Well, that's why you were supposed to be trying it on your own. Not in pen.
But then it looks neat in pen.
Well, sometimes we make mistakes.
I'll just rewrite it later tonight.
Sometimes we make mistakes. Well, that didn't change that. Didn't change it much.
I forgot to subtract by 7.
See, someone else makes mistakes, just not me. How did I pick the points I used, guys? How did I pick 2, negative 2, and 1? How did I pick those?
You pull them from
I pulled them right there from my domain. Right from the domain, negative 2 and 1. You see that? And then I knew that somewhere it had to curve because it's a parabola, it's quadratic.
Wait, would these circles would be open, right?
Yes, but you're using the same one, negative 2, 1 was shared.
What about the third one?
The third one's in between negative 2 and 1, so it's included.
So I close it?
Mm-hmm. Everything in between there's included. I picked 0 because I figured somewhere in there was that told me how far it had to go down, at least, right? Could it go down further, maybe? Yeah, but at least I have an idea, yes? Okay, does that make sense? Questions, guys? Okay, so the next one, what points am I going to use there?
2 and 10?
I'm going to use 2 and 10. Why am I going to use 2 and 10?
Because these are the things.
They're the endpoints of my, right? So equation 3, I'm going to have negative 4 minus 2, which is negative 6, right? So 2, negative 6. And then, why am I picking 10?
Because it's the end.
Because it's the upper, right? So I get 10, negative 14. So I may need to count a slope so I get a better picture that's on my graph, correct? What is the slope of this line right here?
4. I mean negative 4.
Mm-mm.
X.
Negative 1?
Sure.
What's in front of your x, Jaden?
A 1.
A 1 and a negative 1, correct?
But this 4 was the thing for last.
No, because it's y equals mx plus b. M is always the coefficient of x. 2 is the coefficient of x, so the slope is 2. Negative 1 is the coefficient of x, so it's negative 1. So we're open circled at 2. 2 negative 6, is that shared? No?
Shared.
Like, just 2 negative 6 is I'm going to start over here. No. So at 2 negative 6, it needs to be an open circle. Why do I know it needs to be an open circle?
Because it's not included.
It's not included.
You went open.
No, not on mine. And then 10, negative 14. Well, I don't have negative 14, so I better count some slope, right? So down 1 over 1. Down 1 over 1, down 1 over 1. And then do what?
Make a line.
Now, when you guys are doing these, you should be able to go to negative 14. Right? I can't. See how there's a gap on this one? See that? Okay, we have an open circle at 1 because it's not included when x is 1. And we have an open circle when x is 2 because it's what? Not included. Does this graph exist between 1 and 2?
No.
No, there's absolutely nothing on that graph between 1 and 2. So a piecewise function, did we do it all at one time? Nope. We did it in what? Pieces. We plugged in endpoints and we did pieces. Question before I go to the next one.
Hold on.
How many are there?
Writing down the
I think there's one more. You guys making them huge or what?
Yeah.
Dang, Carly's got. I think Ainsley has the entire paper for one. She's like, I wanted to see it.
I just like making my cups.
I know. I like them big too, but we're good? Okay, so we're going to do them all at one time?
No.
Yeah.
Nope. We're going to do what? Pieces.
Oh, what the?
Pieces. Oh, this one's fun.
No, it's not.
What kind of a line is just 3?
A line?
What kind of a straight line?
Linear.
Yes, it is linear. It's a specific kind of linear line.
It's a vertical.
Horizontal, because y is 3 every time. Okay, so y is f of x equals 3 from negative 4 to negative 1, negative x from 0 to 2, and 3 minus x from 2 to 4. So what's my lowest number I'm using? Negative 4, and what's my biggest? 4. Okay, so equation 1, what am I going to plug in?
Nothing.
Nothing, because it says from negative 4 to negative 1, the answer is what? 3. So negative 4 comma 3. Yes?
What? When?
Right here. It says from negative 4 to negative 1, the answer is what? 3. And when it's negative 1, what's the answer?
3?
3. When it's negative 3, what's the answer?
3?
3. When it's negative 2, what's the answer? 3. Get what I'm saying?
But negative 1 is still 3.
Okay, so open or closed at negative 4, 3?
Open.
Open. So negative 4, 3. I love how I have to do my opens. Okay. Open or closed at negative 1, 3.
Close.
Closed. And then connect the 2, right? That would be called a constant, wouldn't it? Connor, you might want to stay awake. Riley, what's next?
We have to do the x, the negative x one.
Okay, so the equation 2. Oops. And so I'm going to start with what?
0.
0. So negative 0 is what?
0.
0. So the point is
0.
0, 0. What am I going to stop with?
2.
2. So negative 2 is negative 2, right? So it's 2 comma negative 2. Now this is linear, correct statement? Because it's, what's the exponent on this?
1.
It's a 1, so it's linear. So I'm going to put open or closed at 0. At 0, 0, is it going to be open or closed?
Closed.
Closed.
I thought you said -0 wasn't a thing.
Negative 0 is 0. It's not a thing. Okay, open or closed at 2.
Closed.
Closed. And I'm going to connect them with what kind of a line?
Solid.
Just a straight line, right? This one's easy, huh? Now what? Equation 3. Evidently, I like that marker. Okay, where am I going to start, Bladen?
Well, you're gonna have to do something.
What number am I going to pick?
3.
Minus 2. Why, Carly?
2.
Because you plugged the 2
You plug the left end point, right? So 3 minus 2 is 1. So 2, 1. And then I plug in the what end point? The right end point. So 3 minus 4 is what? Negative 1. So I'm going to have 4, comma, negative 1. Now this one is linear also, isn't it? No curve on this one, is there? Okay, open or closed at 2, 1.
Open.
Open. Open or closed at 4, negative 1.
Open.
That just seems so wrong to me. That looks funny. But it's not. And what am I going to connect them with?
One.
So do I have some gaps in this graph?
What?
Some gaps in this graph?
Yes.
Yep. Just a gap between 0 and negative 1, don't I?
Yes.
But other than that, we're covered. So, again, did I do them all one time?
Why can't we learn this first?
No. Yeah, this is easy. This is
That's good. I would rather do hard examples than easy ones. Okay. Oh, there's another. Oh, no, it isn't.
That's what we just
We're gonna
did.
say the same one.
Okay, now we got to write an equation.
Oh, I don't like that.
How many different equations do I have?
3.
3. Okay. So I'm going to have f of x equals, I'm going to put a swirly bracket.
You have to figure out everything?
It's not that hard. Okay, so I'm going to start where? Where's my smallest x? Right here? What value is that? What is that right here?
Where are you thinking?
Right on the blue dot on the screen.
-1 or it's -2.
Negative 2. So they're going to be negative 2. Is it going to be equal to or not equal to? At negative 2.
Not equal to. Or
Look at the dot. It's equal to. Why is it equal to?
this is- yeah.
The dot's filled in, yes? Is less than equal to x, which is less than equal to or not equal to? The blue. We're looking at the blue, guys. Is it equal or not equal to on the right hand? Not, because it's open, yes? And what is that x value? It tells you. What is it? 1.
-1.
No, the x.
Oh, that is 1.
The x is 1, yes? Okay, so that is my domain there.
Wait, how'd you get -2? Oh, from the bottom point?
Well, negative 2 is your x. The bottom point is here, but that x is negative 2, correct? So now we're going to do the red domain, just because we want to stick with domains. Keep our brain straight. Where does red start? It's the smallest x.
1.
1. Equal to or not equal to?
Equal to.
Equal. Why is it equal to?
That's filled in.
It's filled in. X, which is less than what? What's the last? 5. Is it equal to or not equal to?
Equal to.
Equal to. And you know it's because it's red, right? Not green?
How'd you know which one of these to start with? Blue, red, or green?
I just start at the left.
So,
You start at the left.
I don't like that.
And that's not 5, is it? Yes.
Yeah, that's
And it's equal. It wasn't right. It was irritating me. Okay, then green.
5.
5 to what?
8.
Is 5 equal to?
I don't know.
Probably not because it's in red, right? And is 8 equal to?
Yeah.
Because why?
It's filled.
Because it's filled in. Okay. So I want to start with green because that looks easy. What kind of a line is green? It's linear, but it's what?
Come into the office. and
It's
take your
constant,
meeting
yes?
when the bell
It's
rings.
constant.
Oh.
So what is the
This is
y
the
every
city
single
needs to
time on
see
that line?
students Before they
8.
leave today.
So that equation's
Abby
what?
Shirley,
8.
Tracy Thompson, Pat Adams,
See how easy that was?
Lisa Harris,
My brain can't focus
Brody
on
Ullman,
talking.
I know, but I want to try to get this one
Cole
finished.
Thompson.
Okay,
SBLA members,
so now I have to go to this line, yes?
Richard Hughes.
And I have 2 points. Can I write a linear equation? I have to find the slope and I have to find the y-intercept. We've done that already this year, haven't we? So how do I find the slope?
IAC first.
Y equals
And
mx
don't
plus
forget, tomorrow
No, the
is
slope.
Outlaw
8
Cowboy Day.
minus 4
And here are a few
over
words
5
to
minus
define.
1. Yes?
Oh, yeah.
So it'd be 4 over 3. Yes? So now I have a slope. I need to find for y equals mx plus b. I need to get my b, correct? Yes. So pick a point. Which one? 1, 4, or 5, 8? 1, 4? Okay, so 4 is y. What's the slope?
Free entry into the event.
4 over 3.
4 over 3. What's the x? What's the x? What's the x?
I'm lost now.
She said we're using this point. The y was 4. What is the x? 1.
That was the most confusing question.
Plus b. What's x?
Yeah.
Okay, so I have 4 equals 4 thirds plus b. How do I solve? Subtract 4 thirds? Yes?
Yeah.
So common denominators would make that 12 thirds, correct?
Yes.
So 12 thirds minus 4 thirds is what? 8 thirds. So b and m, yes? So we get y equals 4 thirds x plus 8 thirds. So I put that where? Right here. 4 thirds x plus 8 thirds. I don't have to graph it. It's already graphed, isn't it? I just had to write it. So how do I find the blue one?
The same thing?
The same exact way. So slope is, this one is what? -2,
Yep.
7, right? Is that what you guys would say?
9,
Oh, 9. Hello.
10.
It'd be 10. Because if
No, because this
Multiply
is
twos.
2, 4, oh. So -2, -10?
Yeah.
Okay, so -1 minus a -10 over 1 minus a -2. So 9 over 3, which is what?
1/2.
How about 3?
Yeah.
9 over 3 is 3. So pick a point. -1, -1, or -2, -10.
Negative 1. 1, negative 1.
Okay, so I'm plugging it in here. What's y?
Negative 1.
-1 equals, what's m?
3.
3
1.
times 1 plus b.
B.
So -1 equals 3 plus b. So b equals what?
3.
I also
Negative
need
4.
Shelby Marsh to come to the office.
So here's -4 and here's 3, yes?
Yes.
So y equals 3x minus 4. Do you now see why I made you practice this already?
Yes.
Okay. We still got to do not pack up. That is not a pack up button. That is for me to know when to wrap it up. Angela, question.
Isn't 5 minus 1 4?
5 minus 1 where?
Right there on our slope. 8
In
minus
the
4
red.
is 4, and 5 minus 1 would be 4.
Oh, which would be 1, which would have made it easier. But that's okay. Yes, you're right.
So I just,
You know, if you have 1 and you did it right. 5 minus 1 is 4, not 3.
okay.
Yes? And that would have been easier. But that's good practice, right? Fractions are good practice.
I was confused
Now.
all the time with the fraction.
It's okay. You can fix it. But it's okay. You're going to have fractions. They're not all going to be nice numbers, are they? Okay. So I didn't have to graph those that time. I just had to write equations. And we've practiced that already this year. You can't, like I said, you can't forget yesterday, today. You've got to keep going. Everything in here just links. Every single thing we do is carried over to the next day. So on your assignment today is a worksheet.